At this point, I want to bring you up to speed with what's been going on. You've seen all the parts and the way I've cut them and some of the things that I've designed as part of this model, and they're just things that over the research that I've done, things that I thought might be helpful to have with a model. And so now I'm to the point where I built a prototype. Prototype was flown, and it did okay, considering I'm new to ornithopters. And but the one thing that I had, or the one issue I had, was this shaft was bending, and of course it was aluminum. So then I had some stainless steel ones made, and actually even had a couple of guys make. Well, one guy in particular, he made one that actually seen the one of the videos, and then I had another buddy that he made one and give to me, and so I was using one of those, and then of course the ones that I ordered, I had a machinist make these for me, so I have plenty of those. So that is no longer an issue. Well, once I went to the stainless steel, and that was no longer an issue, then I wound up not getting the performance that I was looking for. And so in the flights that I made, I had 5 flights, and actually all 5 of those flights were videoed, and it's in the maiden flight. You can see the model did fly, and it was actually pretty impressive. So I since built a second model, and it didn't fly well at all. And actually, there is the video update number 13, which I will post it now because I had made it, and a few people have seen it, but I didn't really post it for the simple fact that I don't mind that if I have a problem. What I mind is when I don't have an answer as to why I have a problem. And so with that, I have now, I think, figured out what my problem was, and I want to share that with you. Let me move all of this, because we'll talk about this. And actually, before I get to this, let's go ahead and talk about the wing. Now, I've done a few things with the wing. This is the template that I used to make the wing that I have there, and of course I've got the board down here. There's another template. You may recall seeing this template. This was a template I used for the tail, and basically what I did was put it down, traced around it. There's some notches. You may recall seeing those notches. And that just gives me a line, and then I take and draw the line, and those are the marks for the tail. So this is the tail template. This is the wing template. Now, a couple of things that I've done, and I'm going to make another change, and I'm just sharing this with you because I'm all about sharing the information. Some people get mad when I do that, but you know what? If I learn it on my own, then I have every right to share it if I wish to do so. And usually I wish to do so. So what we do is we'll put this, and there's some marks. I have some lines on my template that you probably can't see that are not showing up in the video. But there are some marks here. And these marks tell me where to put the backbone. I also have some little marks that tell me where to put the carbon, the small carbon. Now right now this carbon runs from here to here, but on that wing that I flew today, I actually brought the carbon all the way back and had it intersect here. Because of the way the wing flaps, it's actually getting a pivot point back here. To see if I move this up, see, and it's going to be solid here, and it's actually going to be hinging here. If I move this up, my pivot point is not here, my pivot point is there. So what I'm considering doing on this next wing that I do is to move this point, leave it up here, but take it to that point instead of back here. That way it's at the right location here and not here. Now the other thing was, and we'll just use this so that I can show you, but we're going to take a real close look here. And this piece of carbon on my other wing stopped about right there. And what I noticed was this wing was actually rolling, or the material was rolling. It was rolling up. So I wound up having a really high curve here. So I had basically under camber on the wing. Well, I cut that tape, pulled that piece of carbon out, and extended the length of the carbon to go from right flush on the front here. So that carbon, this piece of carbon crosses over this one. So it goes from here all the way back and again to the backbone, which is here. But this is what I want to change. I'm going to take this piece of carbon, instead of having it here, I'm going to have it go to the outside edge here, which again would be right there. Because again, if we move this up and you take a look at where the pivot point is, see what it's doing there? If we look here, it's creasing here, and the crease should be out here. So basically I'm going to take this and move it so that it's going from this point back. And then that way this will flow and give me a little bit more area toward the back edge here. So the other thing is I reinforced the trailing edge both on the top and the bottom. And the reason that I did that is because I noticed my material, the other material, was stretching here. So I pulled it back together, and you can see that it's kind of pleated over here, but it's because this was stretching. So taking it out to this first rib here, or first piece of carbon, actually gives this some strength, because this tape doesn't stretch. So this could actually be thinned up a little bit and made to look prettier, I guess. But for right now, we just want to get the concept right and make sure that it works. And then we can worry about dressing this up so that it's a nicer finish, if you will. But the point being, this wing worked really, really well with this carbon all the way over the top edge. And I say worked well in that I was able to play with the glide today, and I had the wings almost straight across, because I took the glide locks off. I've had the glide locks off for the latest testing, because I didn't care about the glide lock. I needed the thing to fly first, and then I'll worry about getting the glide lock on. But what I had today was, after you look at the video number 13, I believe it is, you'll see that I had many attempts to fly with zero success, and I could not figure out what the problem was. And so the other day I went back out, and again we launched probably I'm not exaggerating, we probably launched 15 times. And out of the 15 times, I think I had 3, maybe 4 really good flights. And I could not figure out what the problem was, because sometimes you would launch and it would go out and turn and make a dive into the ground. And sometimes it would go out and it would just, like it was quit getting lift and would wind up into the ground. So yesterday I took and actually put it up in pigeon mode, is what they call that, where it's all the way up. And then I took a square and set on the table, and then I measured on both sides. And actually I found that this tip here, or maybe it was the other one of them, was a ½ inch lower than the other one. So in a sense what I was doing was I was inducing that turn, or that dive, because it was basically trying to turn in a circle. So once I found that, I made the change, and now today I went out and flew 14 flights, 14 perfect flights, ranging from 4 minutes to about 5.5 to 6 minutes, depending on whether or not I was using an 800 milliamp battery, 1100 milliamp battery, or 1300 milliamp battery, all 2-cell batteries. Now, the reason that the two were different was because I was experimenting with the cam, and the cam is the length between the center of this gear and the point at which this comes out. So this would be the cam, and that's the part that dictates how far up and how far down this goes. So that cam length is what I was experimenting with. And if I take a look in here, sorry, I'm not better prepared. If we take a look here, you can see this is one I was experimenting with. And what I did was I cut several of these. Notice on this one, this cam here is marked number 1. This cam here is not marked because this was the original one. And actually this was the third one that I cut. But my point being this, if I turn this away and I set this like this, now you can see both of these are the same in that this screw here would go through that hole. Of course, the big hole is the lower hole, and then there's a pocket here for a nut, for a lock nut, and that would go there. What I want you to pay attention to is look at the difference. See the difference, the distance between the shoulder here and the nut. And now look at the difference. This is where the shoulder would be, and see how close that is in. So this is a short cam, this is a longer cam. Well, the cam that I have in there right now is in between these two. So it's a little bit wider here, but not quite this wide. And what I had done was I had a cam that was like this, and then a cam that was like this. So they were not the same, so therefore it was basically inducing a turn because one wing was traveling up and down more than the other wing. So with that change, now I have the cam both I'm using, they're the same size, and of course, like I say, today 14 flights, and they were 14 flawless flights. I mean, the model handled really, really well. The other thing was about the glide. I was able to stop it so that I had almost straight across, no dihedral in the wings, and the model flew. Now, one thing that I did do whenever I hit this glide mode, I actually pushed the tail or the stick forward, so which would push the nose down. And by doing that, it did not have a tendency to stall or fall off of the glide with it straight across. So what I'm going to do is whenever I start working on my glide locks again, I'm going to have a glide lock that's going to have about that much dihedral on it, almost flat. Because the other thing that I noticed is whenever I went into that glide, the model, it had a slow descent rate. In other words, it flew along, and again, I pushed the nose down, which kept it into this glide. If I'd have brought the nose up, then maybe it would have stalled. I don't know. It was just really exciting to see that actually I got it to stop there, and it stayed with that glide until I got out of it by adding power. The other thing is, if I go and set it about like that, which has a little more dihedral, and that would probably work good if there was if it was windy, if there was more wind, because I had both a little bit of calm, but most of the time the wind was blowing, and again I was able to stop it in different positions because I had the glide locks off. So by testing that, I figure I'm going to do one like this, and then one where they're almost straight, just a little bit up, just ever so slight up, and we'll go from there. But the great thing about the design here is that you'll be able to have two positions. So if you want more, then you'd be able to alter the glide lock and give yourself more. Because if I start with almost nothing, then you can take that and add more. You can add more, it's just hard to take away more without making another piece. So the idea is to figure out what works the best, and then you'll have one for that, and then you'll have another one you can kind of experiment with. So, but I'll worry about that at a later time. Right now, I just wanted to get the model flying, and I figured out how to do that today. The other thing that I changed, along with this adding the support back here and bringing this all the way up, was I moved the tail. Now what I did with the tail is, if you look at the servo, the way the servo was mounted, on the original one, the servo was mounted where the tail was sticking up. So this servo, the output shaft of the servo was up here instead of down here. What difference does that make? Well, think about it. I've learned, and I've been told, and I've experimented with, and it seems to, the guy was exactly right. The servo, because the output shaft is down now, that's actually lowered the tail. And whenever you're flying, you don't use a lot of elevator. So it's not like conventional aircraft. And I found this out after testing what I was told, and it seems to be true. So you don't use a lot of elevator. In fact, you basically, what I was doing today was I was launching, keeping it flat, and then I would actually push the stick forward, which brought the tail down. Now granted, the tail doesn't come down ever below that, but I was able to pick up speed and then kind of bump the nose or bump the tail up to pitch the model up, and then again put it back down. So what I was doing by pitching the nose forward, or pushing the stick forward, I was able to gain some forward momentum or airspeed and turn that into altitude by just pitching up quick and then letting go. So the model would actually pitch and stay at that angle until it bled off and started flying neutral again, and then I would just do the same thing again. So I figured by lowering the tail, I was actually lowering the effect on the elevator, and that seemed to work pretty good actually. So I'm going to go with those features in that we're going to mount the tail, the servo, like this, and I'm going to change this and bring it out to here. But again, I'm going to do some more testing and make sure that these changes are actually working to better the model, because I don't want to go backwards. And then I think that's about it for the model. Now, what I will show you on the wing, if we take a look at this pattern, again, this is a pattern that I used to make that wing over there, and I plan to change it a little bit, but all in all, I'm just going to make the change back here with this carbon, and then this will all be stuck to the material, the fabric. And the other thing that I'm going to do, or that I've done that I don't think anybody has done, is that my other hobby is making parachutes, sewing parachutes for paraplane models. And I've been doing that since the early 80s, so I've been doing it a long time. But what I'm going to do is, this piece of material here, my pattern, actually has a 1-inch hem. So basically the leading edge is right here. This part here folds over, and then I stitch it back about 3/8 of an inch. And then after it's stitched, then I cut this off. So I wind up with a hem and then about 1/8 of an inch or so of material on the other side of the thread line. And then of course I tape it off like I did that one over there. And I don't use near the tape that was on the other wing that I had. So I figure if I'm using less tape, then the wing's got to be lighter. So that's the reason for not using a lot of tape, is try to keep it light. The last thing I guess to go over here is, because I hem this seam, I'm stitching it. Then whenever I put the tape on, I'm reinforcing it, And then I put this carbon on, but again, I'm going to be changing the carbon to go from here up. And I want to make sure that this piece of carbon goes over and is flush on the front side of the wing carbon, or the leading edge carbon. So I figured I would share those couple of things with you in this update. And I just wanted to let you know that don't worry about number 13, because you'll be able to see it now. And I think I've solved the issue, and I'm going to continue to move forward. But for right now, that's going to be it for this update. If you have any questions, by now you know how to get a hold of me. Thanks for your time, and enjoy the hobby.